We see like the presenter view just
Sorry, you see what?
like the presenter view. We see your slides on the left-hand side and everything, which is fine. We don't really care, but it's not full screen. There we are.
Okay.
And we are recording, right, Rylan?
Yeah, it just started.
Great.
Awesome. Okay, so today I'm gonna so the name of this talk is Enhancing LLMs with Retrieval Augmented Generation, short for RAG. So today we'll talk about LLMs, embeddings, vector search, what, why, and how to RAG, what RAG is. I'll do a short live demo as well. So why does any of this of what I'm going to be talking about today matter? Oh, I'm sorry. So a little bit about me. You've heard this already. But why will any of this? Why does any of this what I'm going to be talking about today matter? So Gen AI, LLMs have taken the world by storm. Companies are adding LLM-backed features to their products. There's a massive rise in Gen AI-based startups. Companies are trying to figure out how to quickly grow competency in this field. And so LLMs are artificial neural networks with general purpose language understanding and generation. They kind of exploded in popularity after the Attention is All You Need paper came out. And they excel at lots of different things like text generation, translation, summarization, paraphrasing, sentiment analysis, classification, chatbots, which are kind of like conversational experiences, and not so much reasoning. So when software development teams are building applications with LLM as a backend, they're still running into a lot of different issues. So some of them are the hallucinations that I'm sure everyone has either heard about or witnessed firsthand. So LLMs tend to make up data or provide inaccurate data, and also sound very confident while doing so. So this past Monday's OpenAI announcement, they mentioned that now their GPT models are going to be trained, are going to have the data. They've been trained on the data all through April 2023. You know, it's still out of date by a couple of months and LLMs still present inaccuracies. Sometimes the relevant knowledge, and this is very use case specific, is not leveraged. So to address some of these, we're going to talk about RAG. But before we get there, we'll talk about some of the concepts that RAG is comprised of. So vector embeddings. So it's a machine learning technique to represent data in an n-dimensional space. If you take a word or a phrase or a sentence or a body of text, put it through an embedding model, then what comes out on the other side is an array of size n with float numbers, and LLMs are used to generate these embeddings. And what happens in this embedding process is that the meaning within your text, within your phrase, within your sentences are encoded in an embedding space, or it's also called latent space. So here's a kind of very simple example illustrating this concept in a 3D space. So these vector embeddings typically are they range from like a couple hundred dimensions to like 1,000+ dimensions. So our human brains can't visualize that data. So in order to illustrate this concept, I'm showing it in kind of a 3D space. So you could see, for example, this graph on the left-hand side. You could see that the man is equidistant from woman as the king is to the queen. So presumably we can calculate the distance from the man to king and calculate that kind of royalty factor. Take the concept woman, take the vector embedding of a woman, add the royalty factor, and arrive in that kind of queen latent space. Here's another 2D example. So you could see that the phrases that are semantically similar are grouped within are grouped together. So top left corner are the sentences that are kind of greetings. Bottom right corner are phrases that talk about soccer. So when we talk about vector search, we're talking about similarity search or semantic search. So it's a search by meaning and not a keyword search. And there's various different ways to accomplish that. So what essentially we're doing when we're doing vector search is we're calculating a vector embedding for a query at hand. And we're trying to calculate the distance to all the closest data points. So the two algorithms that help us accomplish that are KNN, K nearest neighbor, and ANN, approximate nearest neighbor. I'm not going to go into the technical details, but ANN is typically a little bit faster, although that comes at a cost. It's not as accurate, and there's different ways of calculating that similarity. So you could see on the right hand side of the slide, there's different ways to calculating these distances between different points in the latent space. So this takes us to retrieval augmented generation, RAG, popularized after this paper that came out in 2020. Although it feels like everyone is building RAG systems nowadays. So it's a methodology to ground the LLM in the most recent, up-to-date, and accurate knowledge. So a typical standard use case for building a RAG system goes something like this. So let's say a company has thousands of pages of proprietary documents. They want to enable their staff to service customers or have customers kind of do self-service via a chatbot interface. The problem that searching through their massive library of these proprietary documents can be slow and inefficient and lack context. So a typical solution nowadays is creating a chatbot where you would utilize an LLM and a vector search database and enrich it with your proprietary data, and then have your employees or external users interface with this system. So a typical RAG workflow looks like the following. So step one is, so a question or some sort of a prompt comes into the system, and the first thing you want to do is you want to retrieve the relevant knowledge, and typically you would utilize the vector search database behind the scenes. Then that knowledge is taken and put into a context, and you would take that context along with the question and some instructions and put it into a prompt that you would send to an LLM to generate generate the answer. And so the instructions in this case would typically be, again, use case specific, would typically be some sort of further instructions or boundaries for the LLM to follow. So you might say that I want you to provide an answer that's short and sweet, concise, and straight to the point. And if you don't know the answer, don't try to make something up, and only use the data found in the context. So again, just to wrap this all up again, to illustrate this workflow. So you can see that the question comes in, we tap into the knowledge base, we get the relevant knowledge along with the question, we send all of that to the LLM and get an answer back. And this leads me to Langchain. So I started building this in early May, and been very fortunate to have quite a few contributors to help out with this this project. But it's a library for leveraging LLMs to build RAG pipelines and do vector search, chatbots, and some workflow automation via AI agents as well. There's also a Langchain RB Rails, which we're kind of building and trying to lean in closer into the Rails ecosystem and make it really easy to be able to add Langchain RB capabilities into Rails apps. And I'll show a very quick demo. I guess,
If I have questions, you want me to save them for the end?
Please, yeah.
Okay.
Okay, 1 second. I'm just resharing my terminal. Okay, can you guys see my terminal now?
Yep.
Great. All right, so I'm in the Langchain RB repo. So what I'm going to do is I'm just going to invoke a console with kind of the whole gem loaded in there. And basically what I'm going to try to do is I'm going to try to build a really quick and dirty RAG experience for a document that I have, and the document that I'm going to use is a summary of benefits from my health insurance company. So those are typically not very straightforward, confusing by design, contain a lot of boilerplate. You know, I find that you can never tell whether you're covered or not, and until you're actually getting the bill in the mail. So the first thing we're gonna do is we're gonna decide on what kind of LLM we're gonna use. So in this case, I'm just gonna use OpenAI. We can use either models provided by Google Palm or grab one off of Hugging Face. There's also an option to run a local Llama 2 model from Facebook, Meta. But in this case, we're just going to use OpenAI. GPT-4 is still kind of the strongest model out there. So I'm going to declare a variable and assign it to our, this is going to be our LLM provider. Oh, sorry. BI key. Okay, so this is our LLM. And now we have to decide which vector search database we're going to use. So I'm not going to kind of walk through the whole vendoring process and the decisions that that have to be made, and the trade-offs that have to be kind of assessed. You know, there's a lot of open source and proprietary hosted solutions that have and commercial companies that have kind of propped up and blossomed this year. So whether it's Weaviate or Quadrant or Milvus or PG Vector, you could choose and use any one of those. So this time I'm just going to use ChromaDB, which I have running locally in a Docker container. So we're just going to say Chroma client vector search Chroma. I'm just going to look up what the method signature is. So we're going to provide the URL. And we'll call our index, let's say medical docs. And we need to provide the LLM since, index name, apologies. Okay, so we have a instance of an LLM that we're going to be using and an instance of a vector search database that we're going to be using. The reason why we're passing the LLM to the vector search database is that the LLM is going to be used to generate the embeddings for the data that we're going to be sending and indexing into a vector search database. So I'm going to access this local file that I have, and I believe it's located under my downloads folder, summary of benefits.pdf. Assign it to the PDF variable. Make sure we have a default schema created in our vector search database, and now we can actually just add data to it. Specify the paths. You can also specify URLs, and it's going to download the data off the internet. So you can download a README or an HTML page. Some of the other file extensions that we support are JSON, CSV, docx, XLXS, etc. Kind of the standard files. Okay. Let me try that again. Let me just destroy the schema. So as some of you know, OpenAI has been having some issues today, so I'm wondering whether we're seeing it. Okay, true. All right, so let's go ahead and ask some questions. So so we have our summary of benefits for my medical insurance plan indexed in a vector search database. We have our we're using Langchain RB to offer some RAG capabilities on top of this. So let's go ahead and ask some questions. So for example, we can say, well, what kind of plan is this? What kind of plan is this? And sorry, and this is a full response, so I'm just going to tap into the direct text completion. So this is a PPO plan. What kind of plan is this? Which tier? I.e. gold or platinum, etc. Okay, so it's silver PPO plan. We can ask something about specific benefits, like we could say, what is the deductible for the year? Deductible for the year. Or what kind of copay? would I have to pay for ambulatory services? Okay, so I would have a 20% co-insurance copay. So one thing that is very challenging about building these RAG system is doing evals, so doing evaluation. So evaluating the output. There are so many permutations. There are so many different questions that I can ask. I mean, you know, I'm interfacing with some medical documents, but you know, what would it say if I asked it like what the meaning of life is, or you know, something completely unrelated, or some sort of a edgy question about the current events, you know, the evaluations are very difficult. So there's kind of several different ways how people do it. There's human evals, which people also kind of jokingly refer to as vibe check. So basically eyeing, basically testing out your system and kind of feeling it out, seeing if it feels good, given the questions that the types of questions that you're asking it. Of course, it's not very automated. One paper that I saw and we have implemented in Langchain RB is called the RAGAS paper, which stands for RAG assessment, and they've created some metrics to evaluate the output. So I'll kind of show you how to use it here. So for example, so we asked this specific question. So let's go ahead and assign that to our question variable. The answer that we get back, yeah, let's just get a response back, full response object back, and then we'll assign the context that was passed to the LLM to generate the answer to the context variable. And we'll also assign the answer to the answer variable. So the eval tool that we have available, like I mentioned, is called the RAGAS. You would just instantiate this tool and pass it the LLM, because it does use GPT-4 to kind of evaluate it. And then you would just have it score your question, answer, and context pairing. And if OpenAI API doesn't fail us, we should get a score back. Okay, so that's our score. And the RAGAS score itself is a combination of those 3 different scores. And I'll explain what those different scores mean shortly when we come back to the slides. So typically what you would want to do is, if you're running this type of system in production, you want to be collecting metrics. You want to monitor your system. So you want to collect this type of quantitative data over time and see whether you're trending in the right direction. So, you know, for this one-off example, it's probably not something that we want to jump right in and start implementing improvements to our RAG pipeline. But if we tracked it for a week with a couple tens or a couple hundred users, I think it would give us a more scientific approach then. So we will jump back to the slides now. Okay. So optimizing RAG. So one thing I mentioned is doing human evals. So I'm sure a lot of you have seen this upvote, downvote feedback that you could provide to OpenAI. So they are using this data, this feedback to optimize their system. And this is kind of RAG optimization 101. You should definitely be collecting this type of data for a RAG system. There's the RAGAS metrics that I mentioned, the tool that a set of tools that we have implemented in Langchain RB, and some of the criteria that it measures is the faithfulness. So ensuring that the retrieved context can act as a justification for the generated answer. So again, ensuring that the LLM didn't just pull the answer out of thin air, that it's grounded in the context. Context relevance. So this is a measurement of how good of a retriever you've got. So that the context that you provide to an LLM is focused and little to no irrelevant additional information is in it. I'm sure you all are aware of the token limits that these different models have. So we don't just want to dump the whole document in there. It also gets costly because you get charged per token. And the additional metric is answer relevance. So that it ensures that the answer actually addresses the actual question and doesn't just answer, doesn't hallucinate and offer some sort of unrelated statement. So this is a fast-moving field, an emerging field. There's a lot of kind of research that gets posted daily. So huggingface.co/papers is a good place to check. And this is from a tweet that I came across from someone that sat in a OpenAI Dev Day presentation, not the one that was live streamed, but kind of the breakout sessions that they were running. So OpenAI is actually doing RAG as well. So a lot of the functionality that they've rolled out this past Monday is powered by this methodology. And we could see that they rolled out a system and they started out with 45% accuracy. They tried a bunch of things, bumped up to 65%, and then ended up at 98%, which is probably what we see now in production. I haven't gotten the access to the new set of tools, so I haven't personally played around with it. So what are some of the things to look ahead? I've noticed that a lot of people are talking about graph-based databases. So one like Neo4j, and structuring your knowledge not just in a vector search database for semantic querying, but also architecting the relationships in a graph database. I don't have much experience with Neo4j. I haven't really looked into the topic, but it's something to keep an eye on. Here's some references and a lot of good reads here. I created this survey. It's very it's kind of focused on Gen AI and LLMs. I would really appreciate some folks providing some feedback, especially folks that are actually working with Ruby and AI, and the data will be anonymized and provided to everyone. So the results will be shared. And that concludes the talk. Thank you. Any questions?
Dan, no questions?
Yeah.
Daniel has a question?
Oh, so if your RAGA score is bad, how do you improve it? What do you do to actually improve the model?
That's a great question. So you could see a list of different things that that OpenAI took a look at. So first of all, they assessed whether the cosine similarity is the distance metric that they should be using. So if you recall from one of the earlier slides, there's a couple different ways to calculate the distance between the different points in the latent space. So that was the first thing that they scrutinized. Then they tried the hide retrieval. Again, I'm not going to bore you with the details, but it's a link to a research paper kind of describing this methodology. Then they tried using a fine-tuned model. So a model that was used to generate embeddings that was fine-tuned specifically on the type of data that they were going to be generating embeddings for. That didn't work for them. You could see the red X in here in the slides as well. But I think the first thing that I would look at is the chunking, and data chunking is a way of splitting your body of text into different kind of smaller chunks to generate embeddings off of, right? And again, it's very use case specific. So for example, if you're building a system that is meant to answer questions on top of your all of the different employment contracts, right? So that is a very structured document that probably has different sections, right? And so you would look at that PDF and kind of think through what is the best way to split that data up, right? Maybe it's by page, maybe it's by section, maybe it's by kind of by broader theme, right? Maybe you actually summarize the different sections. So again, you would use the LLM to summarize some of the text in the contracts in order to get a more concise version, right? So like get rid of some of the legal boilerplate and just use the meat and the potatoes of the contract. If it's if it's a knowledge base of customer support, let's say it's your Zendesk kind of knowledge base, right? So a pairings of questions that people typically pose to the customer support folks and the answers that the customer support folks respond with. You probably don't want to separate the question and the answer. You probably want to keep them together. So that's your whole chunk, right? There's kind of it's more of an artistic approach. It's more of an art than a science here when it comes to chunking. And I as an engineer, I really wish it wasn't. So. But yeah, great question.
And is chunking something you do manually, or is there support for it in the gem?
Yeah, so there are different chunking strategies by sentence, by character length. There's one that kind of looks at your text and separates it by different themes. But in the legal case that I had described, I would say it should probably be more of a manual approach. Like I'm not sure we would actually code in such opinionated tools.
Mm-hmm.
Maybe.
Cool.
I have a more like just basic question about LLMs and Ruby and all that. So I've learned to code mostly like object-oriented languages is Ruby for me. I've never coded in Python, or at least like in nearly as depth as things like that. But it seems like most of the LLMs that I hear about are coded with something or like paired with something like Python. And can you just like speak to like maybe like why you chose Ruby to work with this, or like the advantages you get from working with Ruby?
Yeah, that's a great question. I actually completely forgot to put in a slide building up a case for Ruby here. So I've been doing Ruby for close to a decade, and I've tried a variety of different languages and runtimes, and Ruby has kind of been the the love of my life in a professional setting. And Python is obviously a leader in the space, and I think early on there's a lot of data science-y libraries that popped up in Python, NumPy, things like that, which kind of which gave Python a head start. There's a lot of Python libraries where they're very compute intensive, and in order to do that, they tap into like lower level bindings like C libraries or Rust libraries. In any one of those cases, Ruby can wrap those libraries as well. And there's kind of, there are those like fringe libraries that people have built where it's an equivalent to the Python library, and it literally wraps the same C bindings, right? Yes, it's an extra effort to build out these tools and make them come to fruition. But I think Ruby is very similar to Python in a sense that it's the same kind of it's a similar syntax. It's the same high level language. It's built on top of C. It also doesn't do concurrency all that well, right? So it kind of has a lot of like similar issues. And the other thing is, I love the pragmatism of the Rails community. We tend to be very pragmatic in our approaches to building solutions and not reinventing the wheel and not overcomplicating the front end, and building a great framework Rails that solves kind of 95% of the real world use cases out there. So that's kind of my aspiration with Langchain RB is leaning into the Rails way, right? The Rails way of doing things, to provide more of a plug and play ecosystem or framework to build these capabilities into your applications. And lastly, I want to mention that I feel like monoliths are kind of making a comeback. In this environment of economic contraction or stagnation, depending on who you ask, companies are looking at their OpEx and are realizing that maybe it doesn't make sense to have so many engineers and staff and manage all this like serverless complexity.
Yeah, thank you.
Thank you.
Any other questions? I have a question, but
Go for it.
you mentioned the word embedding a couple of times, and maybe this is just me being a noob, but like, what's an embedding?
Yeah, let me jump back a couple slides. And honestly, it's completely okay, because when I was learning these concepts, I kind of came from like a web development background. When I was learning these concepts, I had to reread and like wrap my head around this many times over to fully grasp it. So, and a vector embedding is an array of float numbers of a certain length. So it's a it's kind of a mathematical representation of a certain body of text, right? So and the dimensions are actually the attributes that the LLM itself assigns to that concept. If that makes it any more clear.
So it's basically you take a set of documents and you find some representation of them as a vector, and then that can be used by the LLM later to. It basically is like you're coalescing a set of like a specific set of knowledge in a way that the LLM can use it, basically, in the future.
Yeah.
Okay.
Right.
The LLM is what's coalescing it. It's deciding how the semantic meanings of the words are related, or how they get placed in space.
Is it the same LLM that generates the embedding uses the embedding later? Uses the results of the embedding? I guess it's not using the embedding, it's using the results you generate correct me if I'm wrong, it sounds like you generate an embedding using an LLM, using kind of whatever that magic is, and then later you do a vector search, which helps you build the context and the other things that you're feeding back into the LLM.
So when you're sending, so on this step 2 and 3, right? Mm-hmm. You're not sending the embeddings. You're not sending it arrays of float numbers back to the LLM to interpret. You're actually finding the corresponding text that the embeddings were generated off of, right? So you store some sort of a pointer back to the original text, and then retrieve the text that you sent to the LLM.
And then my last question, and I'll let someone else talk, but like that seems like that number one, retrieve relevant knowledge, is doing a lot of work, right? Like, and if you can retrieve the relevant knowledge, why are you bothering to construct a prompt?
Well, the prompt is just organizing the data and like specifying the instructions for the LLM to follow.
Sorry, maybe a better way is what is the LLM? What if you can retrieve relevant knowledge? You're not retrieving the answer. You're just receiving a set of things which you're going to build the answer from. Is that a fair statement to say? Or it's going to help inform the answer?
Yeah. So another way of phrasing it or putting it is you're sending the retrieved knowledge along with the question, right? And I mentioned the optional instructions here, to the LLM to synthesize an answer in natural language, right? So when you retrieve, like if your question is, what is my copay for X medical services, right? And you retrieve relevant knowledge that's just, text blobs with that data, right? But you're trying to present a user with a readable, coherent answer, right? That sounds like it was a human answering your question, right? So you're taking all that data, you're sending it to the LLM and telling it to generate an answer that a human would expect to hear back to that question, right? The way that question was phrased.
Great, thank you. Yeah, that helps.
It's funny, making the answer is actually a key piece of this.
Yeah.
Making an answer that a human can actually relate to and understand. I didn't really appreciate how important that was, and that's one of the things that makes it work so well.
Right.
It's not just a list. I mean, because it's not just a list of like documents that you then have to go in and like get out, right?
That's Google search, right?
Right, totally. Or any other like TTM search. Yeah. Cool. Any other questions?
I was going to say one way I've heard this talked about is it's like auto suggested a little bit, where you feed the LLM, and I think it's the transformer takes the kind of the string of words that you've taken and then replies with the most likely next word. into to form a sentence, and then it refeeds that new string into the transformer, and it's kind of recursive until it can't stop or it can't find any more anything relevant to say.
Right. Yeah. I mean, if you wanna kind of if you wanna offend an LLM, you just suggest that it's a plain stupid token generator. But and I mean, it is right. And some people are saying, well, the typical argument goes something like the following: well, aren't you just the stupid token generator, right? Like, aren't you just kind of predicting, like your brain is just predicting the next words that are going to come out of your mouth? And and they talk about like emergent abilities, emergent reasoning abilities that this training data at scale is helping LLMs achieve. But I think it kind of goes into like some theoretical / philosophical questions here that I'm probably not even qualified to discuss.
You're a developer. We're all you can discuss it anyway, right? Cool. Any other questions or comments?
Okay, you're using the Ragas to get the score. Have you played with putting in different models? Like you had all the different models you could choose from. Using ChatGPT here, but you could choose other ones. And can you ask the exact same question on the exact same data set with the different models? And do you have any feeling for which works better? Is one better for some things rather than others?
Yeah, so kind of rule of thumb is GPT-4 is king and everything else is secondary. And what a lot of teams are doing is they're building their prototypes on GPT-4, or startups are building their prototypes on GPT-4, and then once you're able to prove out that it works, that it accomplishes the business goals at hand, that they have the desired outcomes, that's when they try to kind of scale back and try to figure out, like, is there a cheaper model we could be using? Can we be using can we host the model ourselves? Is there a faster model we could be using, etc.
Okay, cool.
But usually, every POC is created with GPT-4. I mean, that the market share there is far outweighs anything else.
We used 3 to begin with, and then we tried 4, and 4 is obviously better, but it's not worth the cost for us.
Mm-hmm.
Cool.
What's the cost differential for you, Dakota?
I don't remember offhand, because we were just talking about how the cost went down after the OpenAI talks yesterday, 2 days ago. So I don't. It was substantial though.
Not to move the needle.
Yeah, I think it was. Yeah, I think on Monday they mentioned that the input tokens, so the tokens coming in were half the price, right? And then the tokens coming out were a third of a price now. So.
Any last call? Great. Well, thank you so much, Andrei. Really, really appreciate it.